Although y'all don't have to turn on your cameras until we get started with class. We'll get going here in a few minutes. All right, good morning, everyone. Hope you had a good weekend. I've got a bit of an NFL football hangover, not from drinking, just from the drama of the weekend. If you're an NFL fan, last night's game was incredible. So anyway, all right. So I was happy to see that everyone except 2 students were able to complete both of the assignments online. So it looks like most of you have access to everything, ebook and all the assignments, so that's good. What I plan on doing, if we look at our schedule here, our first exam is not till, well, end of February, our first exam. So right now, I'm not having you submit any handwritten work for your homework assignments, right? You're just doing the homework online. We'll do that for the rest of until we get to exam 1. If the grades are good, we'll just continue that. Now, if the grades aren't good and I get a class average that's pretty low, then I might start requiring you to actually submit handwritten work along with the putting the answers in online, which kind of forces you to, show me that you're writing the math instead of just somehow getting the answer and getting them right. So let's see how that first exam goes, and then we'll just kind of adjust from there. All my other classes, my calculus classes, they all have to submit their handwritten work. So just kind of getting you prepared for that. If you plan on going on and doing more math, which most of you have to, you probably will have to be submitting your handwritten work at some point in time. So, okay. The next thing I want to talk about today, right? So today we're going to continue reviewing R7 and R8, and I'll just do it like I did the last class, which is I'm just going to go directly to the homework. I'm going to work out problems, and then as we're doing the problems, if there's something that we need to write down, like a formula or technique or something, we'll do that. And then next time, you do have a homework assignment due Tuesday night at 11:59 p.m. and that is in the Pearson that link to your homework. There are 2 assignments that are due. All right, and those are going to be due at about midnight the night before class. And then remember about your camera for participation. Any questions? Any questions over anything? Questions over previous review problems? Is Gloria here? I don't see Gloria. I don't see Gloria. Okay. Someone had a question about a homework problem, but they're not here. So let me see what's in the chat here. Okay. All right. Well, let's get down to business. No quiz today. I think next class will be a good opportunity to do a first quiz. All right. So that would be most likely what it'll be is you'll come in and I'll send out a poll, and then on screen I'll have like 2 multiple choice questions, and then you'll just like work out the problem and then choose the answer. And then the poll you'll put in, you know, question 1 A, B, C, D, or question 2 A, B, C, D. Does that make sense? We'll do it and then it'll make more sense, but just be prepared to do 2 problems next time covering something from either R7 and R8 or the previous review sections that you've already done the homework for. All right, let's get down to business. So R7, section 7, it has to do with rational expressions. Okay, so that's what we're going to cover today, rational expressions. And then R8, the other thing we're going to do has to do with exponents, roots, and rational exponents. So let's start out with R7, rational expressions, and then I'll let you know when we actually get to the next section. So here we go. This is taken directly from the homework. This is the first question. So the instructions here are to reduce the rational expression into lowest terms. So first things first, what is a rational expression? A rational expression is, first of all, an expression. So there's no equal signs here, right? It's not an equation. It's just some mathematical expression that's just sitting there in front of you. And what we want to do is somehow simplify it, make it look better, okay? Clean it up. There's all different words we can use for this. They use the word reduce and then write in lowest terms. So when we look at this rational expression, oh, by the way, the word rational, an expression is just an expression that doesn't have an equal sign in it, so it's not an equation. A rational expression is any expression where you have a ratio or a fraction. Okay, so in this case, obviously we have this big fraction bar here. And so what we want to do is see if we can't somehow simplify this. So when I look at this fraction, I look at the numerator and denominator, I have to recognize that the numerator is actually what we call a trinomial. And then the denominator is also a trinomial, meaning 3 terms. And so since I you know, somewhere in my past, right, I learned how to factor trinomials. So this is going to be an interesting part right now of today's class. Everybody in here is going to be at a different sort of level in terms of factoring trinomials. So let me start with the fast way of doing this, which I would hope a lot of you can do. And then I'll show you kind of a slower, more methodical way of doing it if you're not sure how to go about this. So for those of you who are at this point, you might be hopefully very comfortable with this. You say, okay, I need to factor this x squared plus 5x minus 14. So you sit there and you think about how you can break this down, factor it, where you're going to get a 5x in the middle term and a negative 14 as the last term. So you have to play with these numbers in your head, and you're like, what multiplies to be negative 14 adds up to be 5, and you come up with x plus 7, x minus 2. I believe that works. So look, again, if you're at this stage where you're doing it the way I'm doing it right now, great. That's where I'd hope you'd be. All right. If you're not, just stand by. I will show you kind of a slower, more methodical way of doing this. All right, next thing I have to do is kind of look at the bottom and say same thing, like, you know, what multiplies to be 35? It adds up to be 12. What's that? 7 and 5? right? Both +7 and +5. So I put x plus 7 times x plus 5. So all I've done here from this step to this step is I have factored, right? That's it, factored the numerator and denominator separately. And then once I factor, I realize that I have common factors both in the numerator and denominator, right? We have an x plus 7. So what I can do is I can reduce this or cancel these. Now I need to say something here that will come back in Calculus 1 that's important on this step. I mean, we've all seen how you can cancel these, right? I mean, that's something, you know, we've been doing for a long time when you have fractions, canceling things out like this. When you do this, okay, when you do this, there's a little asterisk here. You know how you have little asterisks when you're reading something on the bottom, there's a little asterisk. It's like, pay attention to this little thing. There's an asterisk when you do this canceling. This canceling is allowed so long as x is never -7. So you're making me a promise there without actually saying it. You're actually making me a promise that you are going to cancel these, but you're promising me that x will never be -7. Okay, because what would happen if x was -7? What would you get on the top? If x is -7, -7 plus 7 would give you 0, right? And then -7 plus 7 on the bottom, you get 0, and you would have division by 0, wouldn't you? And division by 0 is undefined and not allowed. So what we're doing is we're saying, hey, look, it's safe to cancel these so long as you never are trying to let x be -7. If x is -7, this is undefined, all right? So I'll try and reiterate this more as we continue here. So now this just becomes x minus 2 on top and x plus 5. And that is your reduced lowest term rational expression. Do not go canceling these x's. You can't do that, right? Because you have addition and subtraction between those. You can only cancel when you have multiplication, right? Here we had multiplication right here in green. Between these two things, that's multiplication. And that's why we're able to cancel these x plus 7s. But if you have addition and subtraction, you can't do that, right? So let me just kind of go back to this whole thing about x not being -7. Right now, if I ask you to plug -7 in here, what would happen? Well, let's see, -7, take away 2. On the top, you get -9. And on the bottom, -7 plus 5, you get -2. And that would give you 9/2. And that's a number, isn't it? That's a nice number. Okay, great. But what we are saying, what I'm trying to say here with this little step here is that you are not allowed to do that. Like, you cannot tell me, you cannot go back to this original thing over here and tell me, try and convince me right now that if you plug -7 into that you get 9/2. That's not true. You plug -7 into this, you get undefined. So we always have to be careful when we cancel things, because when you cancel them, sometimes there's this little asterisk where you have to promise me something never happens. And that will peek its head out again in calculus. All right. I'm trying to prepare you for what's coming later. So just pay attention to that. So that's our answer. Let me go to the homework assignment. Here's the actual homework assignment. Let me type in that answer. What did I get again? I got x minus 2 over x plus 5. So the way I do this in this software, let me make this a little bit bigger. I forgot what I have to do here. There we go. Yeah. Okay, that was too big. There we go. Okay, so I'm gonna put the answer here. X minus 2, x plus 5. Check it. There we go. Next question. All right, so we're gonna move on. Any questions on that? Oh, I was supposed to show you the slower way, right? Sorry, supposed to show you the slower way. So if you are at the point where you can do this the way I did it, great. If you're not, then you need to work on this, and you need to take some time for it. This is a review concept. So everyone here should be able to factor a trinomial without it taking half an hour to do so. So let me go through and just take one of these and kind of run through the method on how you can do this a little slower. Now this is actually a lot slower, but let's just do this. So if I'm trying to factor this, what I do is I make sure it's a trinomial. I look at the number in front of the x squared, and I look at the number back here, and I multiply these two numbers together. Right, and that number right there is -14. I'm going to write it down. And there's so many different ways to teach this. The way I teach this back in the lower level classes, I draw on this little like cross thing, this little X, put -14 here. And then you look at the number in front of the X, which is a +5, and you just place that number here. And then here's where you have to actually mentally think about two numbers. Okay, so you have to come up with two numbers in your head that multiply to be this and add up to be this. And that you're just going to have to mess with numbers, all right? Get a calculator out if you can't do it in your head. But at this point, the numbers you would have to get would be your, what were they? 7 and -2, right? 7 and -2. Those two numbers multiply to be -14 and add up to be 5. Now the question becomes, what do you do now with this, all right? With this. Well, again, there's all these different techniques on how to do this. I'm going to show you like a super short way, all right, that you can use and it won't get you into any trouble. Let me show you what you do. You put this two sets of parentheses. You're going to put these two numbers on the right hand side, 7 and -2. In front of those, +7, -2, you're going to put an X like this, X like this. Now I realize that that's the answer, but there's one more additional step that I want you to do. Take this number in front here, right? This 1, right? This is going to be really weird. You're going to put that 1 in front of this X, all right? And you're going to put it below this number over here. All right. In all my years, I've never seen it taught this way. So if this looks weird and new to you, it should. Now, does that actually change my answer? Putting a 1 in front of that X and a 1 underneath that -2, does it change anything? It doesn't. Now, where this is going to become critical is when these numbers are, when this number in front here is not a 1. All right, that's when this is going to become something good, like very useful. Okay, so here it doesn't change the answer, so our answer is still X + 7 and then times X - 2. And then we do the same thing on the bottom one. I'll do the bottom one a lot faster. You understand we're done here? This is X + 7, X - 2. We're good? Okay. And one thing I like about having the cameras on is that when I look up and I ask a question, you can just nod and then I know you understand, right? Instead of having to wait for someone to reply. Okay, next one. So if I do X squared plus 12X plus 35, okay, I take the number in front of the X squared and multiply it times this number, that's 35. I take the number in front of the X, that's 12, +12, and then this is where I had to come up with two numbers that multiplied to be this and add up to be this. And that's where I got 7 and 5. I could have done 5 and 7. The order doesn't matter, okay? Then what I do is I put two sets of parentheses. I put my +7, my +5, X in front of both of those. And then again, this is where I look at that number in front, that 1. I put it in front here and underneath here. Oops, underneath here, which doesn't change the answer. Okay. So that's the factoring. Let's move on to the next problem. I may or may not do the next problem. Let's see. Yeah, let's do this one. Okay, so here's the next one. Perform the indicated operation and simplify the results. Okay, perform the indicated operation and simplify the results. I'm going to take this for a second and go look at this. I'm not a big fan of this. Boy, it's really hard to tell here. Okay, I'm going to put this here. Let's do a little side note. Okay, I want to talk about something real quick. I'm going to put something up here and let's see what you get. What is 12 over 4 over 2. It's 12 over 4 over 2. This is a trick question, by the way. This is supposed to be confusing. What do y'all see? Does anyone want to tell me what they see that's a little bit confusing here? Let me bring up my roster so I can start calling on people. Who did we not talk to last time? Raquel? I don't think we heard from Raquel. Is Raquel here? How's it going, Raquel?
Going good.
Good. What is confusing about this 12 over 4 over 2 thing I put up here? What do you?
When I look at it, it's like, are we supposed to factor them? Are we supposed to divide them, or is it
Yeah,
all
okay.
stacked above each other?
Yeah, so like you could, in one sense, you could be saying what's 12 divided by 4 first, right?
Mm-hmm.
And then 12 divided by 4 would be 3. So maybe this is 3 over 2, right? That's one way. But you could have also maybe done instead of doing the 12 over 4 first, maybe you would have thought, okay, well, why don't I do the 4 divided by 2 first, right? If you do that, then you get 2 on the bottom, right? 4 divided by 2 is 2.
Yeah.
And then you get 12 divided by 2, don't you? Which would not be the same as 3 divided by 2, right? So there's 2 different answers depending on which order I go with here.
Mm-hmm.
So I said this was a trick question. The reason it's a trick question is because the way I wrote it is not right. I did not give you enough information to actually solve this problem. When I wrote this is what I would consider to be bad notation. I need to write it either like this, or I needed to write it like this. In other words, the length of the bar actually matters. How long I made these bars in here actually has an impact on the order in which you do things. So the longer bar, the longest bar you see is kind of like a parenthesis. So it kind of like says, do all that together and then do the bottom together. Separate it that way. Whereas the other one says, do these and then do that one. So do y'all see we're gonna get 2 different answers depending on how I draw that bar? So in the problem we're looking at, it's really hard to see it, but can you all see that the bar in the middle is slightly bigger than the other 2 bars? I mean, it's hard to see it, but it's just barely bigger. So this is like our major bar right here. And so we want to figure out the top and the bottom. Got it? This is just kind of a little side note about notation with fractions and that you have to be careful with the lengths of the bars. Yes? Okay, give me a second. For some reason, my cursor keeps changing. Give me a moment here. That's weird. Okay. I made it so that I made it like custom cursor so y'all can see it a little bit better. And then every time I restart my computer, I lose it. All right, let's get down to this problem. All right, that was just a little side note. Here we go. So we're trying to do this. I'm gonna clear all this out of here. All right, so we're trying to do this here. So I realized that I've got to kind of figure out, is there something I can do with the numerator, something I can do with the denominator? And again, I'm going to be thinking about factoring. So let's look at the numerator, 8x. Can't do anything with that. 8x is 8x. But x squared minus 16, that should make a little light bulb in your mind kind of go off. You should recognize that and recognize it as something called a difference of squares. Again, this goes back to factoring. So today is kind of a review of like, do you know how to factor? So the difference of squares, there's a formula. The formula says if you ever have something squared minus something squared, that it turns into that first something plus the second something, and then the first something minus the second something. That should be something you're familiar with. If you're not, and you haven't seen different squares in a long time, this would be somewhere where you just, hey, I need to go review this, right? So I should recognize that x squared minus 16 can be rewritten. How could it be rewritten, Isabella? Oh wait, Isabella, camera's on, screen's black. Isabella, you're here, right? Oh, you're there now.
Yeah, my camera is, I don't know what's going on with it.
It's cool, you're good. Thank you for letting me know. We're all good. How do you feel about x squared minus 16? Do you feel like you can break it down, factor it?
I'm gonna be honest, no. I'm
No?
trying
Okay.
trying to move with you, and I'm still trying to understand everything.
Okay. Well, this is one of the biggest hurdles we have in math, right? Is that, if you go into a class and the prerequisites for the course, the things you should know going in, if those are weaknesses, which I know they are going to be for a lot of you, that you either have to patch those holes right away, go get help and get that fixed, or if you don't, then you're going to it's going to be a struggle, right? You're going to throw yourself into this thing. That's what makes people hate math, is when the foundation isn't there, it's hard to build on it, right? So you need to, we need, for Isabella and for everyone, just if you're having trouble with any of this, you got to review it. You cannot expect that things are going to get better if we don't have those things filled in. So, okay. But that's an office hours thing. Come visit me, we can talk and, get tutoring, right? Whatever you need. But thank you, Isabella, for being honest, because that's what I want. I'm not trying to humiliate anyone here. I'm trying to help you, succeed. So if you don't know how to do difference of squares, that's a red flag. Let's get it fixed, all right? Gloria, I don't think Gloria's here. How about Zane? Zane, you good? You here? Zane?
I'm here.
Yes. Okay, there you go, Zane. How about you? Different squares? Do you feel about factoring this?
I'm not very good at factoring myself.
Same thing?
Mhm.
Okay, all right. Well, this is what we need. We need to see where we are, right? Ashley, how about Ashley? No, Ashley, I don't see Ashley here. All right, Michelle,
Yes.
how do you feel about it?
I'm a bit confused also.
Also, okay. Let's see. We'll go one more. I'm just calling on people I haven't called on. Henry, are you here?
Oh, yes, sir.
How do you feel about it?
Well, I think it's x plus 4, x minus 4.
X plus 4, x minus 4. There we go. That's it. Okay. So again, if that's something that you need help with, please visit me during my office hours. Take advantage. Go to the syllabus. Click on the tutoring. It take you to the tutoring lab. You can get a Zoom class. Sit one-on-one with someone and get tutoring. I always say come to me first because I know what you need for our class. But difference squares is a concept that we should be familiar with coming in here. All right. All right, so that's what the bottom is, right? This x squared minus 16. And then let's look at the rest of this. Let's look at the denominator. 6x minus 6. Can you factor that? Is there anything that can be factored there? I'll ask for a volunteer on this one. Can you do anything with 6x minus 6 to factor it?
You can bring out the 6.
You can bring out the 6. So 6x minus 6. I'm going to write that. It's a separate concept. It has nothing to do with different squares. You have 6x minus 6. If you're asked to factor that, Alyssa is saying you can take out the 6. Alyssa, do you know what that's called when you did that type of factoring? Like what type of factoring that's called?
No, I'm not sure what it's called.
If I say it, you'll probably remember it. GCF,
Oh, yeah.
greatest common
Mhm.
factor. So what Alyssa did here was said, oh, they both have a 6. can factor out a 6 and rewrite that as x minus 1. That's called GCF factoring, greatest common factor. Again, if that doesn't look familiar, you need to go back and look at that. So we said, let's just kind of back up. 8x up top, we couldn't do anything with it. X squared minus 16 was a difference of squares, and Henry broke that up into 2 pieces here. And then 6x minus 6, Alyssa said, oh, that's GCF, pull out the 6, we can do this. All right, what about the bottom? Let's see, I'm out of colors, but this bottom piece here in red, someone want to volunteer that hasn't spoken about what you could do with that one?
Could you take out 5?
You could take out the 5. Good, Sierra. So Sierra, that's also GCF, isn't it? You're just
Yes,
looking
sir.
for a common factor and pulling it out.
Yes, sir.
So 5x plus 20. Sierra said, oh, pull a 5 out. X plus 4 would be left. Okay. All right, now with all that said, let's now rewrite this. All right, I'm going to rewrite the whole thing. So on the top, we have 8x. Didn't do anything with that. Below that, we had x squared minus 16, which we turned into x plus 4 times x minus 4. And then the big division bar, below that, we had 6, and then x minus 1. We factored out the 6. And then on the bottom, we had the 5, and then we pulled out x plus 4. Or sorry, we pulled out the 5 and we were left with x plus 4. Okay, that's where we are. Any questions on that? Like, assuming you knew how to factor, this is what you would get when you rewrote everything factored, yes? All right, now what we do is, how do we simplify this? This is another very important side note that we need to know going in, all right, to the next step of this. If you ever have a fraction, a over b, and you divide it by another fraction, c over d, that's kind of what we have here, right? It's like the top, this whole thing on top is like a fraction, and we're dividing it by another fraction. Y'all see that? That's called a complex fraction. A fraction on top of a fraction, or a fraction within a fraction. Anytime you have a fraction divided by a fraction, this is the same as the top fraction times the reciprocal of the bottom fraction. That is a property of fractions. You may remember this when you were learning about fractions, that division is the same as multiplication of the reciprocal. That's the way we said it. Division is the same as multiplication of the reciprocal. So taking a over b and dividing by c over d is the same as multiplying a over b times the reciprocal of c over d, which is d over c. So you keep the top fraction, leave it alone, and you multiply by the bottom fraction flipped. I'm about to do that on my next step. I'm going to rewrite this as 8x over x plus 4 times x minus 4. But instead of that big division bar, I'm going to now write times, and now I'm going to write the bottom fraction flipped over. So it's going to be 5 times x plus 4 over 6 times x minus 1. Questions on that? Now, this next step is not necessary, but I'm going to write it. What we have here is 8x times 5 times x plus 4 all over x plus 4 times x minus 4 times 6 times x minus 1. In other words, when you multiply these two fractions, all you're doing is multiplying everything together across the top and bottom. So this all multiplies across, this all multiplies across. And what I need to recognize now is that I have a common factor. I have an x plus 4 can cancel with an x plus 4 there also, right? That happens. Now, this is where you'd have that little asterisk though. X can't be -4. That's a calculus idea. That look, I'm gonna cancel this, but I'm gonna promise you now, X can't be -4, because if X is -4, I get 0 over 0. Is there anything else I can do here as far as canceling or making this look better? Does anyone see there's one more thing I can do?
Couldn't you distribute the 6? Or are we only doing the top part right now?
You mean distribute like multiply it through?
Yes, sir.
You could, yes, you could, but there's something I can do in terms of like, you know how I canceled the X plus 4 and X plus 4? There's
Right.
something else I can do that's kind of like a canceling thing. It actually has to do with that 6.
You can do the 6 and the 5.
6 in the 5 or 6 in the 8?
The 6 and the 8.
Oh,
Yeah, so think about it like if I give you the fraction 8 over 6, could you all reduce that fraction? Right, like 2 goes into both of those, right? So you could just put 4 over 3. Couldn't you do that? Divide each of these by 2. And you get 4/3. We can do that here, even though the 8's way over here and the 6 is over here. Because it's multiplication, we can reduce this. We can make this a 4 and make this a 3. Now, let me write down the next part of the answer and let's see if y'all agree with this. 20x over 3 times x minus 4 times x minus 1. Okay, so what did I do there? All I did was I took the 4, the x, and the 5. That was all that was left on top. I multiplied those together. So I just got 20x. And then on the bottom, all I had was the x minus 4, the 3, and the x minus 1. I just put those 3 together side by side. I put the number first. There's nothing else I can do. I can't cancel anything else out. Okay, there's nothing else that reduces. I mean, that's as clean as it gets. So I'm gonna go try and see if I can put this answer in. All right. 20x. So I need a fraction. I need 20x. Still a little bit too big. 20x, and then it was 3 times x minus 4 times x minus 1. All right. Okay. All right. No questions. We go to the next one. All right, so for the next problem, I'm not going to do this one. It's way too similar to the previous one. All right. I'll just say that, you know, on the top here, you can't do anything with 13x. X squared minus 25 should have a light bulb go off, right? You should see that as a difference of squares. And then on the bottom, can't do anything with 6x, and x plus 5, you can't do anything with that either, right? So you're really just going to factor the x squared minus 25. You're going to do the, you know, fraction divided by fraction, flip it, make it multiplication, and then cancel things out. I think that one is similar enough to the previous one for me to move on. I think that one's also similar enough. There is one tricky thing on this. You know what? I'll do it. There's one tricky piece to this one. Let's do it. Little side something for you here. For those of you who have to take Cal 1, which I believe is almost every one of you. I would be surprised if there's someone here who does not need Cal 1. I always tell my Cal 1 students that Calculus 1, the ideas, the concepts, the theory, right, is actually not that hard, okay? The calculus theory is actually kind of easy to follow. The thing that makes calculus hard is that it's algebra on steroids. So like if you're weak in algebra, calculus will expose you, completely expose you. And so with these concepts, moving into this 1414 class and moving ahead through pre-calculus, if your algebra is a little wobbly, you really want to do everything you can to spend the time, commit the time to getting good with the algebra, because it will pay off. All right, it will pay off when you understand how all these things work and factoring and canceling and all these little properties. When you understand it, feel comfortable with it, life gets a lot better in math. All right. When it's all kind of like, I really don't know if I can do that, and you're always questioning yourself, that's when things get really, really, really bad. All right. So you can learn it. You have to put the time into it. All right, here we go. I'm going to continue with this now. Looks like on the top, I can't do anything. I can't do a GCF, can't pull out a common factor, can't do anything here, can't do anything here. X squared minus 9. I recognize that as a difference of squares. I'm not going to show this step. I'm just going to go right to it. This is x plus 3, x minus 3. And now I rewrite this. But I'm going to write it as the top fraction written, 3 minus x, over the bottom fraction, or sorry, the denominator. But then I'm going to multiply by, is it Malak? Malak? I'm saying that okay?
Yes. Yes.
Okay, Malak. Malak, what would I write next? So it's this times what?
5x.
So you were doing this bottom, Malak, we're doing this bottom fraction, right? But we're flipping it, right? You have to flip it, right? Okay, so what would it be on the top here?
So then it would be the x plus 3 and then x minus 3. And then on the bottom, it would be 5x.
Okay, good. Do you understand that, Malak? Do you understand that I'm
Yes.
using that? Okay, that property that I showed on the previous one, or was it? Oh, I skipped that one. I'm using this right here, right? A fraction over a fraction becomes multiplication of the reciprocal. All right, Malak, while I've got you here, do you see anything that cancels? Do you see anything that goes away?
Not that I know of.
Do you see anything that's exactly the same on the top and bottom? Maybe this will help. What about that in parentheses? 3 plus x. Is 3 plus x the same as x plus 3?
Yes.
Yes. So even though the order is different, with addition, it doesn't matter, does it? Right? I could change this. Like if I wanted to, I could change the order. I can make that x plus 3. Because with addition, you can always change. That's called the commutative property of addition. You don't need to know its name, but with addition, you're always allowed to switch the order. So those two are exactly the same, which means this and this cancel, right? Or they reduce. And then that little calculus part of me says, oh, okay, that's okay. I can cancel that so long as I never let x be -3, because that would make that 0. But that's a little side note. Anything else that cancels? Do y'all see anything? Malak, you're good? How about?
Actually, yeah, I was gonna ask the question because I see the 3 minus x, but I was wondering, could you do that on the numerator since they're both on the numerator and one's not on the
Can you
denominator?
cancel the numerators with each other? Is that what you're asking?
Yeah,
No, you may not.
okay,
So
gotcha.
the whole idea would be something like this. If I gave you this fraction like 5 times 4 over 5 times 3. The idea here is that these 5s go away. Like it's
Right.
common, right? But if you had another 5 up here, you wouldn't say, oh, I can cancel those two. You'd have
Okay,
to-
yeah, I got you. I'm tracking.
No, good question though. Good question. So
So wouldn't you be done for the
Yeah,
factoring
we're
out
done.
at this point?
yeah, we're done. There's nothing here. This 3 minus x, I cannot do anything down here to cancel. This x minus 3 can't cancel. So I'm pretty much done. I would have 3 minus x on top. I'd have x minus 3 on the bottom, or sorry, on the top with it. And on the bottom, just 5x. That should be it. I won't check it, but questions? That would be my answer. So I have a separate question. It's not that problem, okay? It's something, I'm gonna write something similar. What if I had x minus 3, I'll just say times x in front of it, And on the bottom, what if I had 5, and then here I had 3 minus x? So just a second ago, we canceled these two, didn't we? The x plus 3 and the 3 plus x. I said you could rearrange the order of this one, and now they're the same and they would cancel, right? I said with addition, you could do that, right? Now on this one, can you cancel them? So is x minus 3 the same as 3 minus x? Can I just change the order? I see Javier saying no. So it's not true. X minus 3, okay, is not the same as 3 minus x. You don't believe me? Just replace x with 1, right? Let's say x was 1. What would this be? 1 minus 3, is that equal to 3 minus 1? No, -2 is not the same as +2, right? Those aren't the same. Now, had it been a plus, yes, then you can change the order because, you know, 1 plus 3 is 3 plus 1. You'll understand that addition, it commutes, subtraction does not. So you are not allowed here. You are not allowed to cancel these, all right? You'll see that you cannot. Unless you do this, watch. Okay, this is why I'm showing this to you, watch. What I'm gonna do is something tricky. On the top, I'm gonna pull a -1 out of the top. I know this is tricky, but like I said, calculus is algebra on steroids. So here's what I'm doing. All I'm doing is on top, I'm pulling a -1 out of this here. Now I realize there is no -1 on the x, right? There is no negative in front of the x. There is a negative in front of the 3, but not in front of the x. So in order to make this equivalent, I have to put -x here and +3 here. I factored a -1 out. Now, let's just see that what I did is valid and legal. If I multiply this negative times the negative, -1 times -x would give me what? X, right? Which is this guy right here. And then if I do -1 times 3, that gives me -3, right? Which is this guy right here. So x minus 3, what I have in yellow up here, x minus 3 can be rewritten as all of this. Now, why is that useful? Why is that useful? What do y'all notice about this piece and this piece now? You'll notice anything?
They're the same.
They're the same. They're the same. It might be hard to see it, but this right here, -x plus 3 is the same as 3 minus x. Because this is addition, you can switch the order and you can put the 3 in front, and then when you put the -x behind it, it becomes subtraction. Which means I can do what if these are the same? Can I
Cancel them out.
I can cancel them out. So that means I could cancel this and this, which leaves me with the -1 and the x on top. So -x, and then on the bottom, I still have the 5. That would be my answer. That happens in calculus all the time. Not all the time, a lot, I should say, okay? Very frequently in calculus, do you have to see two factors that are almost the same. You have to factor a -1 out and then they cancel. I'm actually gonna do that today or tomorrow in my Cal 1 class. We're gonna do that like probably 3 or 4 times. I'm just gonna like mention it to them very briefly, like, oh, we just pulled -1 out, cancel. It's like, it's gonna be something I'm gonna expect they know, right? Okay. All right, let's move on. Let's move on. Ooh, what a mess. Let me see the next one. Yeah, let's do this one. This one's frightening. All right, we have a complex fraction. All right, this is horrifying. Here's our big division bar. So what I need to do is I need to see, can I factor this? Can I factor that? Can I factor that? Can I factor that? 4 factorings I have to do here. 4 trinomials, each one of them requiring whatever method you're comfortable with. I'm going to go with that short method that that kind of short method that I was illustrating earlier. I'm going to do this. Let's see how it goes. Let's start with this top one here. Okay, you'll realize I have to do 4 factorings. Here's my first one. I take the number in front, I multiply it times the number in the back, which here would be negative 50. Then I take the number that's in the middle here, negative 23. And I have to come up with 2 numbers that multiply to be negative 50 and add up to be negative 23. And I think, is it Annika? Is Annika here?
Yes.
How's it going, Annika?
Good. How are you?
I'm doing pretty good. I'm doing pretty good. How do you feel about finding 2 numbers that multiply to be that and add to be that?
I feel comfortable, but the negatives that kind of throw me off.
Okay, well, just give me 2 numbers that you're thinking. What's in your mind? What's going through your head there?
I'm not too sure, honestly.
So give me two numbers you can think of that multiply to be negative 50, or just even 50.
2 and 25.
Okay, 2 and 25. Let's just write that down. 2 and 25. Okay, so I agree with you. These 2 multiply to be 50, but you need it to be negative 50, don't you?
Yeah.
You need one of these to be negative, right?
Mm-hmm.
But you also need them to add up to be negative 23. So which of these would have to be negative, Annika? If you need to be added?
25.
Then yeah, you want the negative on 25. There we go. See? That wasn't so bad, right?
No.
Okay, so that's it, everyone, right? 2 and negative 25, they multiply to be negative 50, they add up to be negative 23. Good. Now, this is where things get weird, all right? Because I'm showing you like the super short method for this. What I do now is I take these 2 numbers, positive 2, negative 25, x, right? Like this, x here. Now, do you remember I said that what you do now is you take the number in front, that 5, and you do something with it, right? You do something with it. What did I tell you to do with it? Told you to put it here and put it underneath this one, right? Isn't that what I said? Yes? Now, you could also put it here and underneath the 2. So that number 5 in front has to go in front of one of the x's and underneath the number on the other one. Now, look, if you want to know why this works, come to my office hours. I'll show you why it works. I'm not here to show you why it works. I'm here to just give it to you so you can use it, all right? So I get to choose now. Let me write it. Don't write this down. I'm either going to put the 5 here and then divide this by 5. That's one way I'm going to do it. Or I'm going to put the 5 here and divide the 5 here. What you should do, those 2 different ideas, the one you should do is the one that gives you a reduced fraction when you do it. In other words, do you see the 25 divided by 5 is going to give me 5? That's the one you should do. All right? That's the one you should do. You'll have 2 choices when it comes to this step. So I'm going to put the 5 here, put the 5 underneath here, and now let me continue. So this becomes 5x plus 2. And over here, x minus, well, 25 divided by 5 is 5. And that's it. That is the factored form. Now, if you don't believe that that worked, okay, how can we check? Multiply it out. If you multiply here to here, you get 5x squared. Here to here, you get negative 25x. Here to here, you get 10x. And here to here, you get negative 10. And if you collect all, wait a minute, hold on. What am I, did I do that wrong? Not negative 10x, negative, this is positive 2x. I did my FOIL wrong. 5x squared, boom, negative 25x. 2 times x is 2x, negative 10. I'm not sure what the hell I was doing. Put these two together, you get negative 23x. Okay, do you believe that it worked? That's all you need to do is believe it works. So we have factored the top one. Got it? 3 more to go. Let's take some time now. I want you to do the next 3 on your own. See if you can do it. All right. I'm not going to give you like 30 minutes to do it. I'm going to see how much you can get done maybe in the next, I don't know, 8 minutes or so. All right. Now, if you are at a place, if your mathematical algebraic level right now is that you can factor all 3 of those in your mind without using anything, great. Absolutely awesome. I'm not here to try and undo that. That's beautiful. It takes a lot of time to get that good with it. All right. Lots of practice. But this method here that I just did should work for the next 3. See how it goes. All right. We'll take some time. I'm going to put up a poll. Don't do anything on this poll until you're done. When you have all 3, click yes. Okay. I'm stepping away for about 30 seconds, but I will be back. Okay, I'm back. I'm going to start working them out by hand, but not saying anything. I'm just going to work it and you can kind of look at it and see if you're getting the same thing. I'll ask somebody real quick on this one, what numbers they got. Isabella, were you saying something?
Yes, sir. I have a question.
Oh, go ahead.
So, for where we do the X, the whatever's in the 2 left and right sides, that has to equal the bottom one, right? Or it has to somehow, like the minus or negative 25 and 2, how that went to negative 23, that's how it has to be, right?
When you add these, so whatever number's up here, negative 50, whatever two numbers you get have to multiply to be the top number and add up to be the bottom number.
Okay.
Can somebody tell me the number for -16, -7? Did they come up with it?
5
3
and
plus.
-12.
5 and -12?
Yes.
Sorry, Jose, I saw you. You think you,
I was gonna say the same thing. Right?
yeah. So it doesn't matter what order you put them in. It does not matter. Now, look, if you're having trouble with this step, the only thing I can tell you is, you're gonna have to use your calculator or something where you just play with numbers, all right? I'm gonna continue working it out. Okay, are y'all following along kind of how I'm doing this? Are there any questions on this second one that I did, the 4x squared minus 7x minus 15? Any questions on why I put the 4 in front of the x and the 4 under the -12 instead of doing it the other way around? It actually wouldn't be wrong. This is just the way we prefer to do it, okay? It's just easier. If our numbers turn out to be nice like this, it's better to go this way. This next problem is an illustration of where we run into a situation where when we put the 25 in front of the x and underneath the number, there's no nice way to do it. Do y'all see that? This is going to be ugly no matter what. Like, this is going to be a fraction. So I'm just going to have to live with it. All right. I'm just going to go with this. Now watch what happens on the next step. I get 25x plus 10. And then over here, I get x plus, let's see, I have to reduce that fraction. So 5 goes into 10 twice. And then 5 goes into 25 5 times. So we get that. You'll see that? All right, so this is one of the downfalls to this super short method, is that you get this and this looks weird, right? And this looks strange. But it is correct. If you were to multiply this out, you would get 25x squared. Here to here would be weird because you'd have a fraction 2/5 times 25, and that'll give you 10x. And then when you do the middle one, you get 10x again. And then when you multiply here to here, you will get 4. So it is correct. It just looks weird. So there's a give and a take for this method. It's like, it's fast, but sometimes you're going to get some expressions that look weird. Are y'all okay with that? Now, there's one more thing I want to do with this. and this is kind of like the worst case scenario, this problem right here, this part of this problem. I'm gonna do one more thing with this. Let's see if you can follow this. It's gonna be a tricky move, but once I do it, I think you'll appreciate it. Ready? Here we go. Here's what I'm doing. On the first or the first parentheses, I'm gonna pull a GCF of 5 out. There's a 5 in both of those. Y'all agree I can do that? Just pull a 5 out of the first one. Now, I'm gonna put that 5 here. Anyone have a guess as to what I'm about to do with that 5?
Factor it out to the 2/5.
I'm going to multiply it through. That's called expanding or distributing. I'm going to distribute the 5 through the second parenthesis. Now, there's a reason why I'm doing this. When I do that, do y'all see that I get 5x plus 2? Like it distributes through, becomes 5 times x is 5x. And when the 5 hits the 2/5, the 5's cancel and you're just left with 2. So this is the preferred factored form, although what we got before would be correct. Like this is right, but this looks better because there's no fractions in it. All right, we have one more to do. I'm going to have to speed things up here. We've got 4x squared plus 13x plus 10. Going quickly here, I have 40 here, I have 13 here. What is that?
8 and 5.
8 and 5, so you get 8 here, 5 here. So I'm gonna go, let's see, 8 here, 5 here, x here, x here. I'm gonna pop this 4 underneath the 8 and in front of the x. This gives me x plus 2, 4x plus 5. That one worked out a little bit better. I'm going to end the poll because I think we've got what we needed there. So that's it. I'm not done. I need to rewrite this thing. Okay. So let me go back over here. I'm going to make this smaller so I have room. All right, so what we had was the top fraction became, see, the top fraction became this right here. It was 5x plus 2 times x minus 5. That's this. Now the one below it became x minus 3 times 4x plus 5, right? And then we started working on the bottom fraction, this and this. But because it's a fraction divided by a fraction, this is where I'm going to multiply the reciprocal. So I'm actually going to do the 4x squared plus 13x plus 10. That one's going to be on top, which was that right there, x plus 2 times 4x plus 5. And then on the bottom will be the 25x squared part, which we said was 5x plus 2 times 5x plus 2. Okay. So just keep in mind, I did the flipping, right? Because I turned it to multiplication. So I flipped it. Dominic, are you there?
Yes, sir.
Okay, what goes away here?
One of the 5x plus 2 is on the bottom and then one on the top.
Okay,
And then the 4x plus 5.
4x plus 5. That's it. Okay, so what's left on top is the x minus 5, the x plus 2, and on the bottom, x minus 3, and 5x plus 2. That should be our simplified reduced form there. I want to show y'all something. I'm done with this problem. Does anyone have any questions? I want to show y'all something. It's off topic, on topic. What about this thing? X squared minus 16. That's a difference of squares, right? And everyone should know that this turns into something, you know, without, there's a formula for it. But I just want you to consider this for a second. Wouldn't this be the same as this? Isn't that the same as x squared plus no x's minus 16? I mean, it's stupid for me to write that, but it is correct, isn't it? Now, if that's correct, use that method I just showed you. Multiply that times that, you get negative 16. And then what's the number here? Henry's saying 0, right? So what two numbers multiply to be negative 16 but add up to be 0? Well, 4 and negative 4, right? And so what I can do is I can break this down. I can say negative 4 here, plus 4 here, 4. I can put x here and x here, and then the number in front is a 1. So it doesn't matter where I put it. I can put it in the front and below. It's not going to change anything, is it? So you get x plus 4, x minus 4. I'm just showing you that this method would actually work for difference of squares also, but you would have to recognize that this is a 0x. It's just a little side note there. It's kind of cool. Math's like that. I mean, it's like very rarely in math do we have things that we give you that say, oh, this only works certain times. You know, it's like give you this formula or this technique, and it's like this should work no matter what, and it does, which is cool. All right, next problem. All right, so this problem is different. I have a feeling we're only going to get through R7 today. This problem's a little different. And the big difference here is that we have subtraction, okay? We have subtraction between these two things. So when it comes to fractions, when you add or subtract fractions, you can only add and subtract fractions if they have what?
Common denominator.
Common denominator. They have to have the same denominators. Then you can add or subtract them. So when I look at this, I see subtraction. I said, oh, okay, I'm subtracting two fractions. Okay, wait, the denominator here and denominator here, they're the same, right? So I see they're the same, I'm happy. I'm really excited about that, because that means all I have to do is take this numerator, 4x plus 1, and subtract from it the second one's numerator. Now be careful there, because you're subtracting the entire numerator. And so you must put that in parentheses so that your negative will distribute through. Okay, so subtracting two fractions, you take the first numerator, subtract the second numerator, and then what is the denominator? It's whatever they had in common. You don't do anything to it. It's just 3x minus 4. So let me distribute that through. I got 4x plus 1. Distribute the negative through, negative 3x plus 2. All over 3x minus 4. The 4x, take away 3x, that's x. The 1 plus 2 is 3. And you get this. That's it. Subtracting fractions or adding fractions requires the same denominator. If we don't have the same denominator, things are different, which is about to come on the next problem. Are there any questions on this one though? Everybody see how important it is that I distributed that negative through, and that if I had not done that, it would be wrong, right? I would have messed something up. Okay, this one's different. So I was rooting for the Bills last night. And when when the Chiefs had come back and scored and there was 1 minute left and Chiefs were winning. My wife's not a football fan, but she was like watching me go crazy. And I told her if the Bills come back and score with 1 minute left, it'll be a miracle. So they come down, they score, and there's 13 seconds left. And she's like trying to give me high five saying, you know, like, yeah, they're going to win. I said, there's 13 seconds left. This is Patrick Mahomes. Until I see zeros and it's over, I'm not celebrating. And sure enough, they lost. So that's a crazy game. Still recovering. All right. So sorry, I'm subtracting two fractions, right? Do they have the same denominator this time? No, right? No. And this is where things get messy, right? So let me just remind us. Let's say I had 9/3 minus 5/7. Let's say I asked you to do this, right? You would have to get a common denominator between these. So you would have to look for some common multiple of these two numbers, which in this case would be 21, right? 21 is a multiple. So you'd have to basically turn the 3 into a 21 by multiplying it by 7 on top and bottom. And then over here, you have to multiply the 7 by 3 on top and bottom to make it a 21. And then you multiply across, right? You get what, 63 over 21 minus, and then over here, you multiply across the top, you get 15 over 21. And now you can put them together, right? Because they have the same denominator. That all look familiar? Subtracting two fractions. We have to do the same exact thing with this, but we're not playing with numbers now, right? We're playing with expressions. So what I'm going to do is I'm going to take this fraction, multiply it by x plus 8 on the bottom and the top. And then this fraction, I'm going to multiply by x minus 2 on the bottom and top. And just keep in mind, you're going to do this multiplication and this multiplication separately before you do any subtraction of anything. So let me multiply this first one over here. When I multiply the 9 through here, I get 9x. I don't like that color. Let's do 9x plus 72, right? Because 8 times 9 is 72. That's over. Now on the bottom, I'm actually not going to multiply these two together. I'm just going to leave them written x plus 8 times x minus 2. I could multiply them, but I'm not going to. Minus, now here I distribute the 5 through, 5x minus 10 all over x plus 8, x minus 2. They now have the same denominator. Right? Are there any questions on that step? It's exactly what I did over here when I multiply the top and bottom by 7 or 3. It's just this time we have to see like, okay, this one has x minus 2. It's missing an x plus 8. So I need it on top and bottom. And then here it's got the x plus 8, but I need an x minus 2. That way they both have the exact same denominators. No questions? Caitlin? Did I call on Caitlin? I feel like I called on Caitlin. No? Is Caitlin here?
I'm here.
Hey, Caitlin, how's it going?
I'm good.
Good, good. Can you give me what the new numerator will be when I put those two fractions together? You don't have to clean it up. Just tell me what to write down, and I'll just write it, and we can figure out what it is in a second. You can just tell me what to write.
Would it be 4x
Good.
plus 62?
Plus 60. So you got the 4x by doing. Let's write it out.
Okay.
Okay, let's write it. You had the 9x plus 72, right?
Mhm.
That was this one, right? And then you were going to subtract what?
5x minus 10.
Yes, and put it in parentheses, Caitlin,
Oh, okay.
right? But you got the 4x right, but I think it was the other part you, yeah. The other part,
Yeah.
distribute. Is it Caitlin or Catlin? Am I saying it right?
It's Caitlin.
Caitlin, okay. Okay, so you have to put that minus sign there and then distribute. So let me just go to the next line. The next line will be 9x plus 72. We subtract the 5x minus 5x, and the subtract becomes plus 10.
So it's
Then what are your
82.
Say again?
It's 82.
82, yeah. Okay, good. So this will be, here's where you get your 4x plus 82 all over the x plus 8, x minus 2. Okay, good. Questions? Common denominator, fractions? No questions?
So you can
Yeah.
just leave the denominator like that?
You can,
Um,
it's not wrong. You could multiply it out if you'd like to.
Okay.
The computer will take both answers, either left factored or multiplied out.
Sounds good.
Yep. Ooh. Ooh, that's ugly. Okay, so this problem. All right, so we have two fractions, right? We have subtraction between two fractions. They do not have the same denominator. All right, they don't. So watch my first step. This has to be your first step here. Watch this first step. Okay, so what was my first step? I factored these, didn't I? Now, I didn't show any work for those, right? I didn't show you any work, but that's where you would do what we did here on these problems, right? You would have to factor those trinomials. So I did that without actually showing you, all right? So that's my first step. It's just, I'm trying to figure out what do these denominators look like factored? And then I'm going to see what they have in common. This one has an x minus 2. This one has an x minus 2. This has x minus 1. This one has x plus 1, right? So what I'm going to have to do is this. I'm going to have to take my first fraction. I'm going to have to multiply top and bottom by x plus 1. Because that's what the other denominator has that this one doesn't. And then let's see, Zachary, what am I going to multiply the other fraction by on top and bottom? Is Zachary here?
Yeah, I'm here.
Oh, there you are, Zachary.
Let's see. Would it be the x minus 1?
It's the x minus 1. Yeah, that's what the other fraction has that this one doesn't. So they both have an x minus 2. Okay, great. So I don't have to do anything with that. This one had x minus 1. This one had x plus 1. They have to have a common denominator. So I have to create an x plus 1 on this one. And on this one, I need an x minus 1. And now I'm going to do the same thing we did before. I'm going to do all of this first, then all of this together, multiply them, and then I'll subtract them. So when I multiply the top of the first one, I have to distribute the x through to get x squared plus x over this big, ugly common denominator. And Henry, this is why I did not suggest you multiply through in the previous one, because this you really wouldn't want to multiply through. And it's not wrong to do it this way. Here, distribute x squared minus x over the common denominator. All right. Questions on that? Distributing the x through here. All right, I think it's Michael. Michael there? Michael G?
Yes, I'm here.
How's it going, Mike?
Good.
Good. How do you feel about this, putting this together?
So the top, you just subtract the two numerators, right?
Yep. So let's write it down. You would write, how would I write it? X squared plus X, right? And then minus, then what would I put, Michael?
Parentheses,
Good, parentheses.
and then x squared minus x.
Okay, good. And that parentheses is gonna help you remember, right, to distribute.
Yes.
All right, go ahead and distribute that, and let me know what the next part here will be. So when you distribute the negative, Michael, what do you get? Here and here.
So I'd get negative x squared,
Mhm.
and then it'd be positive
Plus,
X.
plus, right? Good.
Yeah,
Plus
plus
X.
x. Sorry.
Yeah. Good. All right, that's good. Now. Sauna,
Sorry, I had myself on mute. Yes.
it's okay. I am saying your name right, right? Yes, Sauna.
Sana, yeah.
Sana, but hold on. Sana, I'm trying to think of a way I can. Yeah, that'll help me. Sana. Sana, all right. Sana, what happens here, Sana?
So it becomes do you combine
Yeah, put that all together. What happens there?
the x squared minus the x squared? Can we do that? Yeah, cancel that.
They're gone. Mhm.
And x plus x, is that just 2x?
2x, yep. So 2x over all of that stuff, right? X plus
Yeah.
1, x minus 2, x minus 1. There we go. Good. Messy, messy. So go to the next one. Any questions before I move on? Oof. This problem's the same thing. Same exact thing. Except, yeah, here the numerators were a little nicer than these. Let me see here. I'm just looking at what's left. Okay, so this one's the next problem. It's done the exact same way as the previous problem, so I think I'm going to leave that to you. Let's take a look at this one. Perform the indicated operations, simplify the results. All right, well, this is a weird looking thing. You got 1 over G, that's a G, not a 9. And then you have 9 over 3x plus G minus 3x. Just strange looking. Strange looking. So let's start this. And there's different ways to go about it. Let's work in the parentheses first. Okay, so let's just work in the parentheses. We have 9 over 3x plus G equal, or minus, sorry, 3 over x. So I'm just working on what's inside that parentheses first. I'm going to figure out what it is. So I'm going to subtract two fractions. They have to have the same denominator. So I have to multiply this fraction by x over x. And this fraction, what am I going to multiply this one by? Lizette, are you there?
Yes.
What do I multiply that second fraction by?
You're gonna multiply by 3x plus g.
Yep, 3x plus g. Top and bottom. All right. You want to keep going, Lizette? They sound like you feel pretty good about this. So what happens on this first fraction? What do I get on top? And then on the bottom, you don't have to multiply it for me.
So it's just the numerator is 9x.
Okay. And the bottom is, let's just put it like this, x parenthesis 3x plus g. Is that okay? And then what about the other one? Minus, what do I get here? You have to multiply this out, right?
Yes.
Don't do the minus. Don't worry about the minus yet. Just do the distribution of the 3 through here. And what would you have?
So 9x plus 27.
9x plus.
Oh, wait.
Okay, yeah, it got you, didn't it? You treated the g like a 9.
Yes, I did.
Yeah, be careful with that. Be careful. So
So
this 3 hits
9x plus 3g.
3g. There you go. Okay. I think they're doing that on purpose to try and get you to mess up. I'm guessing. Because they could have used any other letter. They use G. Now we can combine these, right? Jose, we can combine those together. I think you're muted if you're talking.
Sorry, yeah, I was. So I guess we'll combine the top ones.
Yeah, and you can do this all at one time. If you want to distribute the minus however you want, just tell me what to write.
So it will be 9x,
Okay.
and then it will be minus parentheses, will be -9. No,
So
no,
if you're gonna put the parentheses, right? If you're gonna do this minus and then parentheses, just
it will
write down
multiply
what's-
it. Right, it will be
Just-
9x plus 3g.
Yeah, just keep it exactly what it is over here. And then on the next step, you can distribute the minus through.
Yeah.
The bottom doesn't change, right? It's just the same
Yeah.
denominator. So now go ahead and distribute the minus through. Well, let's take our time. It'll be 9x, and then what do you get when you distribute?
-9x
Mhm.
and -3g.
3g, yep. All over the common denominator. Okay.
Yeah.
And what do you see, Jose? What happens there up top?
9x and -9x cancel out.
Yep.
It would be just -3g
Yep.
over x parentheses 3x plus g.
There you go. Okay, good. All of that is just us simplifying out that parenthesis, right? That's all that is. Go with me? With us? Everyone good? We still have in front of it a 1 over g, right? And there's multiplication there. So I'm going to put 1 over g times, so this up here, I'm working with separate work over here. It's 1 over g times this answer, -3g over the x times 3x plus g. And let's see here. Javier, are you there?
Yes, sir.
What do you got? Do you see something there that we can do?
Can you, would you multiply the x or like take it, or how do I say it? Like x times 3x plus g?
You could distribute this. Yep, you could distribute the x through, which wouldn't be wrong. I'm wondering though, Javier, do you see anything that simplifies or becomes nicer?
No, I don't.
Look up top and then look on the bottom. What do they both have in common?
The
You see
g?
something? The g. Y'all see that? You can cancel this g. Right? There's g on top and g on the bottom. There's multiplication. So this will just become -3. And then over, now that the G's gone, you have the X and then the 3X plus G. And Javier, you could multiply that X through, but you don't need to.
Okay.
This would be fine. Okay. So we're at the end of class. We still have 7 minutes, all right? And there's some more problems, but the problems towards the end, you remember I told you I wanted to kind of let you have some challenge problems at the end to see how y'all do. I'm gonna just kind of give you some pointers right now on how to approach these last ones. This one right here, what you do to start, you rewrite it as 3/1 plus 1/x over 5/1 minus 1/x. And then you put these two together. You combine them, so you have to get a common denominator. Then you put these two together, so you get a common denominator there. Once you have that put together, then you go back to this thing. Where was that formula? Where was that one? Remember this, where you had a fraction over a fraction becomes multiplication of the reciprocal? You'll do that. So you got to do some combining together. Then you will, take the top and multiply by the reciprocal at the bottom, and then things will cancel. See how it goes. This one, put these together. Once you get those two together, like right as 3/1, then put those together by doing division. And then once you do that, put it together with the 1. You'll have to write the 1 as a 1/1. It's going to be messy. I just want to see how you do with it. These are called complex fractions, and they're complex. Let me see. And then the last one, let me see. Yeah, the last one, what do they want? Yeah, see how you do with this one. Just multiply, come on, where's my, multiply the 5 through, multiply the 2x through, clean it up and see if you can get anything to cancel out. So see how those last 3 or 4 problems go. In terms of homework, all right, and what I want you to do tonight, the only thing that's going to be due online, the only thing that I'm going to have you do is the R7. All right, that's it. We didn't get to R8. So I'm going to go into the system right now, and I'm going to change the due date for R8 till next week. All right, but I expect that everyone's going to have gone through the R7 homework by the next time we meet. And like I said in the beginning, this is the time for you to reach out if you need help with factoring. The tutoring, let me show you this. I'm going to go to, I'm curious on my own what happens here. I'm go to Northwest Vista's website. I'm just going to type in math tutoring. Math tutoring labs. So math tutoring labs, one-on-one tutoring, click here. It's probably gonna, yeah, it's trying to open the Zoom session. So I can't do it because I'm in a Zoom session. No, hold on, it is. It's letting me join because I guess I have an account. I'm not going to, well, let me see. I don't know what's gonna happen here. To be in 2, if I lose you, I'll come back. Whoa, what happened?
Hey, Robert, what's going on?
Okay,
good. You got everyone.
Hold on a second.
Coffee.
Debbie, are you there? Debbie, can you hear me?
How can we help you, Robert?
Gabe, I had it. I found it, Gabe.
He's in.
Oh, you did? Okay, because I wasn't able to find it. Yeah, I got it.
Okay, I left. Could y'all hear me talking to them or no?
Yes.
Okay, so do you see that there was a bunch of people in that? I don't know if there's people in that Zoom meeting. If you show up there and say, hey, I just came from my 1414 class. We were doing factoring. I feel lost. They can help you out, okay? They can help you out. just go, I'm gonna send the link right here. Copy link. I'm gonna send it in the chat. I recommend you go in there and you can ask about, what are their hours? I know they're open until the evening. Okay, that should be it. All right. But I'm not saying don't come to me for help, but I'm only available a certain number of hours a day, and it may not work into your schedule. So all the topics that we were covering today would be considered prerequisite topics, and they offer like one-on-one tutoring for those sorts of things. All right. So I think we all understand what's going on. You're just going to do the R7 homework. We'll come back. We're a little bit behind, but it's okay. Well, we need to make sure everyone's up to speed before we move into this class. So questions?
Actually, so on the assignments where we turn in, it says that everything is due at 10:59 p.m.
It says
instead of
10:59?
Yes, sir.
Let me see here. Manage assignments. See, it says 11:59 for me. Are you in a different time zone?
No, sir. I don't know, but I'm looking at it right now. For my other class that I have, it says 11:59, but for your class, it says 10:59.
Is anyone else seeing 10:59 on their end or no?
When I was doing the homework, it said 10:59.
It said 10:59?
I think it was an hour ahead on mine too.
For me, it said 11:59.
That's weird.
Mine
It
says
does say 59 for me as well.
Well, y'all see what I see, right?
Yeah.
I'll double check the time zone, make sure that my time zone setting is correct. Let me manage this. Let me go in here real quick. So R7, 11:59. It doesn't tell me what time zone, but I can switch it. So R7 is going to be due, by next time we meet. R8, as you can see here, I'm going to move this due date to Sunday night, which, wait a minute, hold on, is that right? Yeah, Sunday night. I moved it. There's going to be another one, 1.4 will be with it. We'll see how that goes. I might be pushing 1.4 back. It just depends. But let me save this. Okay. All right, so that's it. Classes, we're done. Unless you have any other questions, I'll hang out for a few minutes, but I'll see you on Wednesday. Have a good day.
You too, sir. Thank you.
Thank you for your participation and cameras on, everything.
Bye, sir. Thank you.
Take care.
Bye. Thank you. See you Wednesday.
Okay, see ya.
Oh, sir, I do have a question.
Yes.
So on it was R2 and R4 due last, right?
Yes.
Today. So when I was doing my like calendar stuff, I couldn't find like the R4, and so I was never able to finish it. Or I was never able to do it. I couldn't find it on my assignments.
When did you try and open it?
I did my assignments, I want to say on Friday, because I was off work, or no, I did it on Thursday.
Okay.
I was off work.
I'm gonna go in here and I'm gonna look you up. I've stopped sharing.
Yeah,
my
I
screen.
found R2, but I never saw R4.
Okay,
But
so
I went to assignments now, and I found it now, and I don't know. I didn't see it last time.
okay, yeah, let me see. I need to check how I can give you like an extension or something. So let's see. It was R4, right?
Yeah, yes.
Setting per student. Today's the 23rd. Or today's 24th. I'm making.
Yes, sir.
Okay, that should. Oh, what the heck? I have no idea what happened there. I just tried, check on your end, see if it changed the due date at all.
Okay, let me, yeah, I have to reopen the.
Lizette, did you have a question as well?
Yeah, so for the questions, I finished them all, but is there like a turn in button or do we just finish them and then leave them like that?
Well, I thought there was like a submit button. Is there not?
Because
a
that's what I
submit?
was looking for, but I remember like